This is Wells Math. I'm going to show you how to subtract with mixed numbers today. Uh, one important thing you need to know is there's a couple different ways to solve this problem. So I'm going to I'll call this one part one. If you want to see the other way that I teach how to subtract with mixed numbers using the regrouping method, go watch part two of the video. I'll work the same exact problem, just with regrouping. So let's get to this way. First of all, I would write down this problem. Pause this video if you need to. 3 1/3 minus 2 3/4. The first thing we're going to do is turn our mixed numbers into improper fractions. If you don't know how to do that, I do have a video with that exact title. But you're going to multiply the denominator times the whole number. 3 times 3 is 9. Then add the numerator to that. So 9 plus 1 is 10. 10 becomes our new numerator. And our denominator will stay the same. So 3 1/3 is equivalent to, it is equal to 10 thirds. Now we'll come over and do the same thing with our 2 3/4. We're going to multiply the 4 times the 2, the denominator times the whole number, that's 8, and add the numerator to that. 8, 9, 10, 11. That will become our new numerator. And that denominator, the 4, will stay the same. So take a step back, make sure you see exactly what we did there. We just changed both of our mixed numbers into improper fractions. Next step. We need to get a common denominator. Anytime you're adding or subtracting fractions, you want the bottom numbers to be the same. Okay, so I'm looking at the 3 and the 4. And what I'm thinking about is, what is the smallest number that both 3 and 4 will divide evenly into? That's also known as the least common multiple. And the first number that pops in my head is 12. Okay, so I'm going to want 12 to be my new denominator. I'm going to come down here and go ahead and write that 12. All right, but we cannot just bring the numerators down. We can't bring that 10 and that 11 straight down. If you change the denominator, you're going to have to change the numerator as well. So what I'm going to do is look at this 3, and I'm going to say, how did I turn that 3 into a 12? What did I multiply it times? Well, I multiplied the 3 times 4 to equal 12. So now I'm just going to come up to the 10 and do the same exact multiplication problem. 10 times 4 is 40. I'm going to go look at my other fraction. 11/4. I'm saying, hey, how did I turn this 4 into a 12? Well, I multiplied 4 times 3 on this side. So I'm just going to do the same thing to the top. 11 times 3 is, what is that, 33. So a couple different steps we did here, but really not that bad. Once we get to this point, you'll see what the rule says to do. Subtract the numerators. Okay, that's 40 minus 33. That is 7. And keep the denominator the same, 12. There you go, 7/12. Now remember, if you want to see another way to solve this problem with regrouping, go watch part 2 of this video. We'll do one more problem here just to make sure we are clear. And I'm going to go through a little bit faster on this one. So if you need to pause the video, feel free. And we've got 4 1/2 minus 2 3/5. We're going to do the same exact thing. We're going to follow these 3 steps you see at the top of your screen. Probably be a good idea for you to write those down to have those as a reference when you're doing these problems in the future. First thing, mixed numbers will be turned into improper fractions. 2 times 4 plus 1 is 9. We will keep the denominator the same. So 4 1/2 is the same as 9 halves. You can call it 9 tooths if you want. I think it's funnier that way. 2 times 5 is 10, plus 3 is 13. Keep the denominator the same. Next step, get a common denominator. I'm looking at the 2 and the 5, and I'm thinking, what's the smallest number that both of these will divide into? Now, anytime you want to get a common denominator, you can also just multiply these two denominators together, 2 times 5. That's not always going to give you your best common denominator or your smallest one, but in the end, you can always simplify your fraction if you need to. So I'm going to say that my common denominator is going to be a 10 because 2 times 5 is 10. I'm going to go ahead and write those down here. But remember, just like the last problem, we cannot just bring those numerators down. You have to ask yourself, how did I turn this 2 into a 10? Well, I multiplied it times 5. So now I'm just going to have to do the same thing to the top number. 9 times 5 is 45. We're going to go look at our 13/5. I'm going to say, how did I turn that 5 into a 10? Well, we multiplied it times 2. And that lets me know I need to multiply my numerator times 2 as well. 13 times 2, if you don't know what that is, get out a calculator. It is 26. Okay. All right, we've got our common denominator. Step 3 says subtract the numerators. 45 minus 26 is, my human brain says that is 19. I don't really trust my brain, but do on that one. And then we will keep our denominator the same. Now you might be saying, Mr. Wells, is this going to be an acceptable answer? 19/10, excuse me. No, it's an improper fraction. We need to change it back into a mixed number. Now, we didn't have to do that on the last problem because when we worked it, we just got a regular proper fraction. The numerator was smaller than the denominator, but not for this one. We need to change it back into a mixed number. I do have a video on that on my YouTube channel if you want to check that out. But every fraction is really a division problem. 19/10 really means 19 divided by 10. Your first number in your division problem is your dividend, and it will go inside the house. Now, this is going to be a pretty easy division problem for work. How many groups of 10 will go into 19? Well, only one. 2 times 10 is 20, and that goes over 19, so we cannot go over 19. But 1 times 10 is actually 10. Caveman knows that. We will subtract, get a remainder of 9. But we will no longer say our answer is 1 remainder 9. That's stuff they do like in 2nd and 3rd grade. From now on, your remainder will come up and become your numerator, and your denominator, which is also that divisor, will stay the same. There you go. If you want to see this problem worked with regrouping, go watch part 2 of my subtracting with mixed numbers video. Y'all subscribe to my YouTube channel at Wells Math. Hope you have a great day.